All right, so we're going to start looking more specifically at rangelands and the different climates that determine which rangelands are going to be more productive versus less productive and really drive forage production. So, climate is defined as a long term pattern of weather, so not patterns, sorry. Um, in addition to temperature and precipitation. So weather is really defined as a short-term variation in temperature as well as precipitation, wind, humidity, all of those good things that we are actually getting to experience for the first time in a while right now here in California. So climate is really going to drive forage production. So that's why we spend so much time talking about different climatic zones. So climates are really going to also strive to define a biome. So a biome is a large terrestrial ecosystem that is easily recognizable. So these are big areas. This is like the entire Great Basin or the Mediterranean climate here in California or annual grasslands. So other areas could be, the grasslands throughout the Midwest. So our ranch in MacArthur is actually kind of on the edge of two biomes, so it makes it challenging to manage cattle sometimes. We are very much in mountain valleys on one side of the hill, and then when we go over to the next valley, which is the majority of our leased land, we're in Great Basin. So simply driving 15 miles east and going up in elevation by 1,000 feet changes a biome. So it doesn't usually happen that drastically. In other places, it's more of a gradual effect. But just realize that a biome is really a large area that it has certain specific characteristics. And then an ecosystem is going to be a subcategory of a biome, and this is really going to be more focused and involved determining the community of the organisms. And organisms can be plant communities, soil communities, insects, wildlife, animals, you name it. So community of all or all living things. In addition to the description or describing the community of organisms in an ecosystem, the abiotic environment is also going to be described. And that leads back up more towards the climatic factors. So, frost-free days, wind, average temperature, those type of things are going to be really kind of weather-based abiotic environments. So climate affects vegetation pattern three main ways. First of all, it's going to affect plant biomass, and it does this simply by determining the amount of vegetation that can potentially grow. So this primarily comes from the form of precipitation. So if you have very, very little precipitation, like less than 5 inches of rainfall or snowpack per year, then you're going to have a really small amount of plants that can survive in that environment. Climate can also affect vegetation patterns by influencing the soil texture and structure. So if we look at here in California in the Central Valley, in certain areas, especially as we move towards the river, our soil goes from a nice sandy loam or a loam to a clay loam. And that clay loam is really indicative of being the deepest parts of that lake that the Great Valley used to be in. So those soil textures could have been driven by a variety of different things, but also could have been driven by climate patterns or precipitation patterns. Because California typically gets more rainfall, more precipitation, has more standing water or more running water going through the river than the Great Basin does. So it has the ability to influence the soil texture. So climate is going to affect vegetation very directly in the form of precipitation. So in areas where precipitation is going to be insufficient for the forests, it's probably going to be too much for the barren deserts. Sorry, that was a dog. So if we look at this figure to the right here, we've got average temperature on the x-axis and annual precipitation on the right axis. So the rangelands tend to be areas that have very low annual precipitation, less than 100 centimeters per year, but can vary or can have a wide array of average temperatures. So we can have very, very cold rangelands or very, very warm rangelands. This figure really shows the annual precipitation across the U.S. and helps to drive and form some of those climatic regions that we're going to look at more closely in just a second. So you guys can spend a little bit more time on this as needed, but basically what I want you to get away or take away from this is that there's a lot more consistency of precipitation through the east and the Midwest than there is in the west. So, and a lot of that has to do with higher elevations, more rugged terrain, and then another effect, the orographic effect that we're going to talk about here in just a few minutes. One of the challenges that range managers has is averaging or managing the year-to-year variation in precipitation. So, for example, this historical data from the city of Los Angeles shows the variation in precipitation from 1890 up to about 2005. And you can see that there were really, really wet years and really, really dry years. So, and if you look at this, you can see like averages within just 1 or 2 years of a major difference of about 10 inches of rainfall per year. So if you're talking about not receiving a total of 10 inches of rainfall 1 year compared to another, that makes for a really large problem from a management standpoint. So that's another challenge that range managers have to face. And this is why we put so much faith and science into prediction models when it comes to predicting precipitation, because those prediction models are going to help like the federal agencies and the private companies set stocking rates for the following year. So now that we have talked a little bit about what climate is and some of the things that different climate patterns can actually do for range management, let's look at the different climate patterns here in the U.S. So we can see we've got a bunch of different ones in the West. There's a lot of consistency through the South and specifically the Southeast. And then as we go up in latitudes, we can see we're starting to get colder and more precipitation. However, when we get to the West, a lot of that area is going to be what we term the semi-arid steppe climate. So this could be partly Great Basin, a lot of higher elevation regions. And then this yellow area here is going to be the mid-latitude desert climate. So this is a desert climate, but it encompasses part of the Sonoran Desert, part of the Mojave Desert, and then part of the high desert all through Nevada. So even though we classify the Great Basin as Oregon, Western Nevada, not Western Nevada, but Western Idaho, parts of Utah, and Nevada, the climate zones within that Great Basin are much different. And then here in California, we have this Mediterranean climate that has been good to us this year, not so much in years past. And then as you move up to the North Pacific, especially on the coastline, you're going to get a humid continental climate where the summers are very, very cool. So spend some time looking at these different climatic zones. Also, just take note that down here, South Florida is the only part of the tropical wet dry season that we actually have in the U.S. When we take a look more closely at the western part of the U.S., the we overlay the climatic regions with the different geographies, we really start to get into a more specific management area for rangeland. So again, we have our Mediterranean climate. We've got a large amount of Sierra Nevada mountains and Cascade Mountains all the way up through Canada. Got a large Great Basin area, then the Southwest deserts, and then the Great Plains, and then also the Rocky Mountains as well. So this is a more detailed map of the different climatic regions, and this gets more specific because you're actually looking at pockets of area that typically receive more precipitation than others. So a lot of this can be due to different mountainous regions that provide a rain shadow effect, and that will become more apparent here in just a few minutes.